back to AP Bio Walkthroughs with Jen. Today we're talking about chi-square analysis. What is it? What do you need to solve it? Why would you ever use it? Let's jump right in. What in the world is chi-squared? Simply put, it is a way for us to determine if the outcome of our data is what we expect for the experiment. And how do we know what we expect? Well, we write something called a null hypothesis at the beginning of an experiment. And in order to say this is not expected, we have to be able to reject our null hypothesis, okay? Classic example of this is with six-sided die. Let's say we got bored and we wanted to do an experiment where we rolled a dice 100 times and we recorded what each outcome of that was, right? So there are 6 sides. Dice are supposed to be random, and so you can assume that every outcome is about as likely to happen as every other outcome. Another way to say that is that we have a 1 to 1 to 1 to 1 to 1 to 1 ratio of outcomes, okay? What this means is that it is equally likely to get a 1, roll a 1, as it is a 6 or a 3 or a 2, okay? And so what we do is we would roll it 100 times and then we would record. But because the real world is random, it might not be that we get each number on the die perfectly 1/6 of the time, right? It might be a little weird, especially if you are only rolling, let's say 5 or 6 times. In order to really see the data, you need a bigger sample size. That's why we're rolling 100 times. So here's an example that's more relevant for you. This is data taken directly from the AP exam 2020 scores. Okay, so I just calculated the percentages for a total of 100 individuals. This is kind of the way that you'll see data presented to you on some of these questions. So we've got our score group. Okay, these are our different quote unquote treatments, okay, our outcomes, right? So if we were making a table of the dice 1 through 6, right, outcomes would be over here. So that's our score group 1 through 5 for the AP Bio scores, and then the number of individuals total adding up to 100. Okay, so we've got our score group 1 through 5, all the possible outcomes that you can get on the test, and then the number of individuals that got that score in 2020. So what we want to do is look at our observed data and see, is this what we expect or not? And that's all going to be based on our null hypothesis, which we'll talk about in a second. So we've been talking about comparing expected outcomes to observed outcomes. How do we do that? We need 3 things. So to perform a chi-square analysis where you're comparing observed and expected data, you need 3 things. The first one is this formula. This is the formula for chi-squared. Here's all the different parts. This sign right here means you're adding something up, okay? This E is the expected. The O is the observed, okay? So what you're doing here is for each entry in your data, you are taking the expected entry and the observed entry. You are plugging them into this, okay, and then you're adding them all up. The second thing you're going to need is something called your degree of freedom. This can easily be found by looking at how many different possible outcomes you have. Okay, so let's take that dice example. How many outcomes do we have? Well, we only have as many as are on the side of the dice, so 6, right? So we have a formula for a degree of freedom. We say n minus 1 equals our degree of freedom. What is n? That's the possible outcomes. Okay, so for the dice, we've got 6 minus 1. Our degree of freedom is 5. Okay, so the degree of freedom is always 1 less than the number of possible outcomes. The third thing we need is something called the critical value, often just abbreviated to CV. You can find this by knowing your degree of freedom, and you basically go look at a table and you find it. And what do you do once you find it? Well, you're going to be comparing your CV to your chi-square value. If your chi-squared is less than your critical value, then you accept your null hypothesis. But if chi-square is actually larger than your critical value, then you have to reject your null hypothesis, okay? So what is your null hypothesis? This is basically what you have to break in order to show that your findings are significant. So let's go back to our experiment with the AP Biology students' exam scores and think about null hypothesis for this data. Since we don't know actually what to expect, right? We don't know if this observed is right on or if it's completely out in left field. We can make a null hypothesis based on something really basic, right? So we've got 5 different groups here. Let's assume that they're all equal, just like the dice. Was observed, that's going to be O, right? And then we can come over here and make another column for expected. So to keep things simple for our expected column, we're just going to assume that every single score group has the same number of students, all right? And so we can do that by dividing 100 by 5, and we get 20 for each group. So the null hypothesis is just a way to basically write out your expected data in words. And so ours would be something like this. Each score was awarded to an equal number of students, okay, across the board, 20, 20, 20, 20, 20. And just by looking at this, we can see that our observed data here seems to be a bit different than our expected data, right, based on our null hypothesis. So in fact, if you look at the students that got a 1 and the students that got a 3, 5 times more students got a 3 than got a 1. Let that inspire you. Also, another interesting thing to keep in mind is that you only need 50% of the correct answers on your test to get a 3. That's a passing grade. Most colleges give credit for 3. Okay, now I don't have any chi-square tables for that AP Biology example, but we do have a real life example, much like you might come across on the actual AP test. We're going to work through it. So that's going to be the next section. So go ahead and get some scrap paper, because you are going to be doing that. Here we go. Inspire.